Hello, I'm Evan Piermont, and I'm going to be talking today about my paper, Failures of Contingent Thinking, joint with Peo Zazu Garin. This paper is motivated by two observations. The first is that there's, in general, a gap between the way uncertainty is modeled in economic models and how it's perceived by actual humans. So it's generally modeled using a semantic state space, which is a set of objects called states, and the states represent complete resolutions of uncertainty. And then uncertainty is governed itself by a probability distribution or some probability-like object over this set. However, in the real world, uncertainty is often doled out as a set of interconnected statements. Things like it's raining or the S&P 500 is going to go up tomorrow. And the connection between these statements is sort of subjective and often part of the interpretation that's part of the decision maker's understanding of the world. Now, rationality assumptions allow us to pretty cleanly translate between one and the other, right? So from this syntactic or language-based model to a semantic or state-space-based model. And it's well known that if you have a model of logic, you can represent it both using the syntax and also in a semantic or algebraic way. However, humans are not sufficiently rational, right? They're not rational, and in particular, not rational enough to allow these kinds of translations to always make sense. And in particular, there's a growing understanding in the empirical and experimental literature in economics that subjects are often very bad at understanding if-then statements or bad at engaging in contingent thinking. Below is a list of references of recent or semi-recent work that comes to this conclusion. And the problem here is that these set of interconnected statements are interconnected exactly by these kinds of if-then statements, right? So the idea that if some hypothesis is true, then another one follows. And so if agents can't do that, then constructing a coherent state space that represents their preferences or their understanding might be impossible. So sort of the prototypical example, a very stark example of this kind of failure of contingent thinking comes from a Tversky and Kahneman paper from 1983, where they provided subjects with the following vignette about a woman named Linda who engages in things like nuclear demonstrations and teaching yoga. They ask the subjects to rank the following three statements in the order of likelihood: that Linda is activist in the feminist movement, that's F; that she's a bank teller, T; and that she's both a bank teller and active in the feminist movement, and that's T and F. And 85% of subjects ranked F strictly higher than T and F strictly higher than T, despite the fact that T and F implies T, and so any consistent state-space model, any model where each state represents a consistent and complete resolution of uncertainty, and you have a probability distribution over this, it must be that the probability of T and F is less than the probability of T, right? It lies inside of it. The states where T and F is true is a subset of the states where T is true. So what we're going to do in this paper is examine a decision maker who faces syntactic or language-based uncertainty of the style I'm describing, a set of interconnected statements where the interconnection is subjective or potentially subjective. And in addition, this decision maker is an imperfect reasoner, which means that she's not able to hold in place in her mind all the logical conclusions of her knowledge. And we're going to ask, can we still tractably model this decision maker using something that looks very similar to a state-space model or is a state-space model? Second, how do behavioral patterns in choice or in the understanding of these statements, the probability of these statements, relate to the rationality type assumptions on the construction of such a state space? And finally, how can we identify or actually figure out which contingencies the decision maker understands and fails to understand? Which if-then statements are the problem in the decision maker's mind? So our model is built on top of this set of statements that the decision maker thinks is decision relevant and harbors uncertainty about. And that's constructed starting with a set of primitive statements, so these things like Linda is a bank teller, and then closing off under negation, conjunction, and disjunction. So it includes all of the atomic statements. It also has the negation, or not something that's of anything in the language, the conjunction, which is two things being true at the same time, and the disjunction, one thing or the other thing is true. At least that's their classical interpretation. Now, a subjective model of uncertainty, that's sort of the model that we're proposing and axiomatizing, and that is a triple, a state space, and a probability distribution, much like the state spaces that are always used in economics. But the extra element here is what we're calling an interpretation. And an interpretation is a map from this language to events or subsets of the state space. And T of phi is interpreted as the set of states where phi is true, or considered true by the decision maker. And that therefore mu of T of phi is the decision maker's subjective assessment of the probability of phi being true. And in this way, a decision which is predicated on the truth of these set of statements in L is faithfully captured by this subjective model of uncertainty using T and mu. Now, of course, T in general will not obey the usual logical calculus, and in fact can't obey it if we want to capture these failures of contingent thinking. So if we go back to our Linda example, the primitive statements are T and F, and there are three states. And we have that F maps to states 1 and 2, T to just state 2, and T and F to states 2 and 3. Now, this is not logically consistent because T and F should map to the intersection of where T maps and where F maps, right? And instead, we have the state 3 in which neither T nor F is true, and yet T and F is true. And while this is clearly at odds with the classical understanding of logic, such attention is required if we want to capture this anomalous behavior that is itself at odds with logic. So we can map out various levels of rational interpretation. So if the decision maker understands equivalence, logical equivalence, then we call T exact. So it maps logically equivalent statements to the same event. And likewise, if she understands implication, we call it monotone. Negation, she's symmetric. Conjunction, she's land distributive or logical and distributive. And if she obeys all of these things, then we'll call the decision maker sound. And that is that's the rational benchmark where it's modeling logical relations, all the logical relations. The primitive of our model is a strict relation, a strict preference relation over syntactic acts. So we're going to be looking at this decision maker's behavior over things that look like bets, and then trying to find a subjective model of uncertainty which rationalizes or explains that behavior. And through this, understand the identification of what kind of rationality assumptions are present in that model that explains the decision maker's behavior, right? As a way of saying what kind of rationality does this decision maker display. So a syntactic act, the objects of our model, is a pair. First, it's a set of contractual clauses, which is just a subset of the language, a finite set of statements. And F, which maps that set of statements to utils or some payoff, right? Some utility level. And there are two pieces of notation. We have X phi is just a constant act over phi, right? So it's not exactly a constant act because it still depends on what the domain is, what the set of contractual contingencies are, but it just maps all of those to the real number X. And we're going to say that two syntactic acts are equivalent to one another using that squiggly sign or approximate to each other if they satisfy exactly the same relations. In other words, the decision maker does nothing to ever distinguish between them, right? So anytime phi F is preferred to something, so is gamma G, if and only if gamma G is. And the object of our paper is to explain the decision maker's preference via a model of subjective uncertainty. In other words, to relate this clunk object with interpretation T. The problem is that given a subjective model of uncertainty, phi and F together don't necessarily map to a function over the state space that we can evaluate using something like expected utility or integration. And that's because if you're not logically consistent, or even if just F is not very well defined, it might not specify a unique payoff on each state. So say that a semantic act, or an act from the state space, the image of this interpretation of the set of statements, if bold-faced F is consistent with flat-faced F, which is a semantic act, if at each state the payoff according to bold-faced F is the payoff of F for some statement which is true at that state, right? This is kind of a mouthful, so I'm going to give you an example in a second that hopefully makes it clear. Well, the point is that this consistency is not going to be a singleton. The set of consistent acts is not going to be a singleton. In general, a semantic act might be, there might be different ways of interpreting it as different potential acts over the state space, right? So an act from statements into payoffs might be interpreted as different acts from the state space into payoffs. And that depends on the decision maker's rationality and also the way the act is specified. So let's say that you have a very simple contract on P and not P, and on P it pays 2 and on not P it pays 3. Now if you're logically rational, this is going to tell you a unique way of interpreting this act, because each state in your state space will be either a P state or a not P state. But if you're not rational, you could have a kind of wacky vision of the world where P is true on states 1 and 2, and not P is true on states 2 and 3. Right? So this decision maker is, of course, not purely rational. In state 2, she believes both P and not P are true. But since we're allowing that, we have this act which is not specifying the payoff on state 2, right? So it maps P to a payoff of 2, and it maps not P to a payoff of 3, and so it leaves the payoff at state omega 2 undefined, right? Because there's not a unique value which it could take. It could either be 2 or be 3. And so the set of consistent acts are the set of acts which are either 2 or 3 on state 2, right? So the first consistent act is this black line, which is the upper envelope, and the second one is this black line, which is the lower value on the of the x. So what's to take away from this is that failures of contingent thinking create ambiguity, not ambiguity in the sense of multiple priors or some decision theoretic issue. They create ambiguity in the colloquial sense of, if I don't understand the world rationally, then when I encounter things, I might not have a unique interpretation of what's going on. This is actually true even if you have a rational interpretation, if the objects you're working with aren't well defined, right? So if F maps P to 1 and Q to 2, but P and Q are not mutually incompatible, then it's possible that, in a state where they're both true, I don't know what I'm getting, right? So a flawed contingent thinking, it's as if acts are ill-defined, right? It's as if they're not well-defined. The decision maker doesn't understand all the contingencies being discussed in some insurance contract. She might not be able to map the insurance contract that she's examining into a unique payoff over her view of how uncertainty could resolve. So the key representation in our paper is an interpretation-dependent expected utility representation. And that says that this strict preference is represented by the expected utility of these semantic counterparts, the consistent acts. But F is the syntactic act F is preferred to the syntactic act G if every consistent semantic act F is preferred to every consistent semantic act G, right? So it's you have to be strictly better in every possible way, every possible interpretation of F and every possible interpretation of G. This leads to a notion of incomparability, right? So this is a strict relation, and it's going to have intransitive indifference, or it's going to have some incompleteness. And what's really going on at a mathematical level is that these are interval-valued representation, right? So each syntactic act, phi f, is mapped to a set of values corresponding to the set of possible interpretations of f over the state space. And when t is sound, so when t is rational, and when f is well-defined, this will reduce each set of consistent acts will be a singleton, and so this whole thing reduces to expected utility, so subjective expected utility. And we axiomatize this in the paper, but in the interest of time, it's not here. And in the interest of space, unfortunately, it's also not in the poster, but I do encourage you to look. We have a version of it that is online. For the last few minutes, I want to talk about the relationship between the observable preference, the decision maker's choices or preference between these syntactic acts, these mappings from particular contingencies to payoffs, and the corresponding rationality restrictions on the interpretation of the subjective model when that preference has a interpretation-dependent expected utility representation. So in other words, if the decision maker's preferences can be explained using the subjective model of uncertainty, what are the relationships between additional restrictions on preference and the structure of T, so how rational is T? And in the paper, we go over conditions for full-fledged rationality, distributivity, exactness, etc. And in the talk, I really just want to focus on implication. I think that that's the key driver in the example, and hopefully it's a clear and clean enough thing that it can be understood even just in a few minutes. So let's say that phi implies, psi implies phi, and then we're betting. So remember that x subscript phi is just a constant act that says I'm betting on some element of phi being true. I get paid x units of utility if any of the statements in phi are true. And so we're betting on some statement in capital phi being true, and capital phi includes lowercase phi or phi. I'm not sure why there's two names to that letter. And we know that psi implies phi. Now, when I say psi implies phi, I mean according to the rules of logic, right? Not according to the decision maker, but according to the traditional rules of classical logic. So it's a theorem of logic that implication holds. So the condition in 1 says that a bet on phi is a bet on capital phi, and the set phi is equivalent from the perspective of the decision maker to a bet on phi and psi, phi or psi, phi union psi, and is sort of a taken word, right? And if we think about what this means here, it means that if I know that I win if any element of capital phi is true, and I can additionally win if psi is true, I get no benefit from that additional flexibility of winning when psi is true. Now, we know that psi implies phi, and phi is one of the original winning conditions. And so that means that whenever psi is true, according to logic, phi is also true. And if I'm already winning when phi is true, then this additional flexibility is really is not particularly helpful for me, right? Because whenever psi is true, phi is true, and I win when phi is true. So we're going to assume that the decision maker recognizes this, right? So that her preference between betting on phi and betting on phi union psi are equivalent. And this is to say that she understands that there's no additional flexibility from betting on psi. And therefore, she understands this implication. She understands that psi implies phi. And we can see this reflected in the representation. So if that should be a strict preference, if the strict preference has a representation where it satisfies this first condition, then there's a representation where T is monotone, right? T being monotone means that it respects, it maps implications into subsets. Using the same idea, we could then think about, well, what if the decision maker doesn't obey this for all implications? We could actually come up with what is the set of implications that the decision maker does understand, and we say that phi subjectively implies psi, when this relationship holds for a particular value of psi and phi. So this is saying that the decision maker understands this particular implication, although she might not understand all implications. So a cognitively constrained or irrational decision maker still might understand some implications, and this is a methodology for identifying them from preference. Finally, it's worth pointing out that we could be thinking instead of logical relationships. So here I was saying, phi logically implies psi. According to the rules of classical logic, it could also be according to the rules of classical logic and some background theory, right? So T is a background theory if it's, some consistent set of statements. So maybe statements like, if water is above 100 degrees, then it's boiling, right? Water being above 100 degrees and water boiling are not logically related statements, but it does seem that at least at sea level to be true that there's this implication between them, right? So that doesn't rely on all rules of logic, it relies on our understanding of some background theory. And we could repeat this entire exercise using implication that's derived from this background theory. So phi implies psi according to the background theory T, when it can be deduced from the rules of logic and knowledge of this background theory T. And so we can work out again, not just what the decision maker understands, but in fact what the decision maker understands relative to the modeler's background theory. And this result shows that we can identify this, what is the maximal set of T implications that the decision maker understands, and if we have additional constraints on rationality, additional axioms of rationality, then it's actually a very easy identification exercise. I don't want to get into it too much, but I want to give you a little taste so that you come look at the poster and ask questions, and we can go over this in a little bit more leisurely pace.